We have looked in the past at position, velocity, and acceleration, each on their own. Then we tied together what they mean and how they're related to each other. We've even looked at their graphs. We haven't really talked about taking any of these measurements over a prolonged stretch of time, just kind of at any given moment. So in this video, we're going to look at instantaneous versus average quantities. Every time that we've analyzed any of these quantities, we've been asking, what's the position right now? What's the velocity right now? These are called instantaneous quantities. You can think of an instantaneous quantity as kind of a snapshot. So this will be our snapshot quantity. Our average quantities, those are taken over a range. This is going to be more of a before and after. Maybe I am looking at a drive that I'm going to make from home to Toronto. I am not particularly concerned about my instantaneous speed along the way, not for planning purposes. I don't care too much if sometimes I'm driving 45 and other times I'm driving 75 miles an hour. What I'm concerned with when I'm planning this trip, when I'm planning my drive time, is my average speed. Now the police car that's sitting at the side of the freeway, he doesn't care about my average trip at all. What he cares about is what's going on right now. That guy is interested in an instantaneous speed. Let me show you what I mean. I'm going to give you a couple of graphs, one of position and one of velocity. So maybe we have a story that goes with this. I am moving along, I am speeding up, so I'm starting from rest, I'm moving along, I'm speeding up, and after 11 seconds I'm 300 meters away from where I started and moving pretty fast, but now I realize I left something where I started, so I turn around and start heading back at a constant rate. My velocity looks like that too. I start at a speed of 0, and I speed up, and then I realize, oh no, I forgot. So now I turn around and start heading back. I do have this spot, this dotted line, and that happens because right here I have a sharp corner in my position versus time graph. Because I have that sharp corner, I'm going to have kind of a cliff in my velocity versus time graph. This thing, this sharp corner, is called a cusp. Maybe with this, I would like to know what my velocity is at 10 seconds. If I want to know my velocity at 10 seconds, that's really convenient because I have this graph. So velocity at t equals 10 seconds. I'm not worried about a time range or anything like that. I'm saying, what is it right at that instant? I have this graph right here, this velocity versus time graph, that shows me at certain times what is my certain velocity. At t equals 10 seconds, I get right here, I get 40 meters per second. This thing that I just found, this is my instantaneous velocity. Instantaneous. Because it happens at that instant, I'm only worried about one snapshot. At t equals 10 seconds, I can take a snapshot and I'm going 40 meters per second. Now maybe I would like to also find my average, so I'm going to do this in a different color. If I want to find maybe my average speed from t equals 0 seconds up through t equals 10 seconds. So the way that might be worded on a question is I want to find my average velocity over the first 10 seconds. Then what I'm doing, I want to know how far I've gone and how long it took me to do that. This is the before and after picture. So let's see. At t equals 0 seconds, that's my before. I get an x value of 50 meters. At t equals 10 seconds, that's my after, I get an x value of, at 10 seconds, here, 250 meters. So if I'm going to find my average speed over that time, I'm going to say my average speed is going to be 250 meters minus 50 meters over 10 seconds minus 0 seconds. 250 minus 50, that's 200. Over 10 minus 0, 200 over 10, that is 20 meters per second. What I am doing when I find an average speed is I am saying, what would it take if I were going at a constant speed to connect my beginning point and my end point? Here's my V average, saying if I'm going to travel at one speed the whole way, what speed would it need to be to accomplish the same result? Was I moving at 20 meters per second the whole time? No. What I was actually doing, I was moving less than 20 meters per second here. And I was moving more than 20 meters per second here. Was I moving at 20 meters per second at some point along the way? Yeah, I was. Right about here, these slopes line up, and I can look. Here is my 20 meters per second. At that point, I was going actually my average speed. If I'm looking for an instantaneous value, I can just read it right off the graph, and I can plug that into the function, or I can plug it right into the function. Instantaneous graph, instantaneous velocity, I'm reading right off my velocity versus time graph. If I want an average, I'm going to go up one level. So remember how velocity is going to be a meters per second, and position is going to be in meters. If I want an average velocity, I'm going to go up one level and find a slope with that graph. If I were looking at an acceleration, if I want an instantaneous acceleration, I can read that right off my acceleration versus time graph. If I want an average acceleration, I'm going to go up one level and read the before and after on my velocity versus time graph and find a slope. Average is always going to be a slope of the graph one level up. Instantaneous is always going to be a read right now type of quantity. That's instantaneous versus average.